All right, hello class, hello professor. This is my final lab assignment for EC 141 computer algorithms. And yeah, so here I go. So the objectives of the lab that I created, main objective is to understand and implement the sorting algorithm called Pancake Sort. And yeah, so in the first task, what you want to do is create a code that allows the user to use the pancake sorting algorithm. And within that code, it must allow the user to enter the number of elements that you want to use in the array. So whether you want to use 10 elements, you want to use 5 elements, 1 element, 1,000, it's your choice. Next, what you want to do is be able to enter the specific elements that you want to use. So don't randomize it, or don't create a randomizer. I want you to input your own elements, and I'll show you what I mean later on. And also, I want you to show both in the code the unsorted array and then the sorted array within the output. And then task two is once you complete task one, uh, I want you also edit the code where the output shows both the largest and smallest element within the array that you inputted. So yeah, pretty simple, not too difficult when it comes to using this algorithm. So yeah, so here's a theoretical background. So what pancake sort is a it's not necessarily too difficult to understand. It kind of mixes up some of the other algorithms that we're using, but it's still a new one. And what it is Pancake Sort is it's a sorting algorithm that works by flipping the subarrays back and forth, similar to flipping pancakes uh, into a stack to sort them by their size. It repeatedly brings the largest unsorted element into the front of the array by swapping it with the element that's in that current position. And then after that, what you want to do is flip it into the correct position, which is at the end of the sorted unsorted section, but it means unsorted array. And after solving it, you learn that the time complexity of the pancake sort for both best and worst cases is O, O, big O, and squared. And here's the limitations of feature work. So the limitations of this lab is we haven't taught what pancake sorting is. So something new that I had to just go on the internet and do my own research about it. And we had to I had to learn like everything about it to be able to implement it into a code. And the feature work is that we can use this information that we learned in this lab to solve future problems using pancake sort. Here are my hardware and software specifications. So yeah, very simple. My CPU is AMD Ryzen 5 5600X with 3700 megahertz, 6 cores, and 12 logical processors. I have 32 gigs RAM inside my PC. It's a x64 based PC. The operating system is Windows 10 Home, and where we type the code is on code blocks version 2003. So yeah, uh, here's one section of the code. I'm going to go more in depth in a little bit when I show the actual code and simulating it. But yeah, so here at the beginning, uh, what this represents is just flipping the first I plus one array in elements. That's all it really does. And it just helps with the to, to find the correct index when using this. Next one, to find max index, kind of similar to the first one, but what it does is besides flipping it, it finds whatever the largest element in the array and creates that as the main index, and it returns the index of the largest array, a largest element. And then the next section is it finds both the minimum and the find min max, pretty much kind of what it says in the name. It just finds the smallest and largest element within the array. So yeah, pretty simple. So yeah, next page. Here's the actual pancake sort implementation. So I'll break this down more in depth. So pretty much what this purpose of this code is to implement the pancake sorting algorithm. And it starts with the current array, which is cur size equals n, and reduces the size of it of the unsorted portion after each iteration. Then what it does next is find the maximum, the largest element in the unsorted array using the find max index right here. So it finds the largest element. And then if the largest element is in the end of the array, what it does is it's going to use the flipping thing, like I showed in the first part, void flip. And it's going to flip it and all the way to the front of the array, and it's going to flip it again to move it to the correct sorted position at the end of the array. So that's pretty much what it means. So yeah, that's pretty much what it does. It just finds each the current the largest element, which is the index, and if it's not already at the end, it's gonna put it in the front and then flip it all the way back into the end, which is its correct position. So yeah. And here's how we have the main function. Very simple. Allows the user to enter their own numbers of elements, which is n. And after that, it enters their own amount of elements. Then next, it will allow them to enter their specific elements so where they want to use, the number 10, 12, 40, of 1,000, 7, whatever. After that, it will display both the smallest and largest element using the find min max. And here, right here, where we have the couts, the smallest element, it'll input the smallest, and then the largest element will input the largest. And yeah, and then under that, it will show the unsorted array, which is the original array that you entered in the beginning, where you entered the elements. It will show that. After that, it will input the array right here, the pancake sort. It will input that array and do what it needs to do to put the elements in the correct position. And yeah, and then after that, it's going to show, after it does the work and all the steps, it's going to show what's the final sorted array, and then that's it. It's going to display the final answer. Here's a basic output. So we answered 5 elements. Uh, I'll just show a live demonstration. I'll be using the same numbers right here too to make it simpler. So here, hopefully you can see my code. So this is pretty much everything I just went through and explained. The flip section, the maximum index, finding the minimum and the maximum element in the array, pancake sorting, and the main function. So here, let's run it. Let's put it on the side. Let's use the same thing on the output demonstration to make it simple. Okay, I'm going to enter, let's do 5 elements. And the elements I want to use 3, 6, 2, 8, and 4. As you can see, it shows the smallest element, and I added these dash lines to make it more easier on the eyes to see. Uh, so yeah, that's the only reason why it's there. You don't necessarily need it, but it makes them look more clean. So here as we have the smallest element, and it's number 2, and so we look as the array that we inputted 36284. We can see that 2 is the smallest element, so that's correct. And the largest element, which is 8, and as we can see, 3, 6, 6 is larger than 3, so that's the largest. 2 is less. 8 is larger, so 8 is now the largest. And 4 is not larger than 8, so 8 is the largest element, and we have that correct. Here's the unsorted array, what we originally put it into the enter the elements section, so that's fine. And here we have is the indexing. So and I'll explain to you how it works. So as I said, what you want to do is find the largest index, which is the largest element in the array. Find that, and as we can see, it's 8. So what you want to do is flip 8 all the way to the front. So we do that by swapping it with 3. So now it becomes 8, 2, 6 through 4. And now that we have the largest element in the front, we can now sort that in the correct position, which is all the way at the end. And we can do that by swapping it with index 4. And now it's 4 and 8 are swapped. So now the next new line of code is 4, 3, 6, 2, 8. And you just pretty much keep repeating that by the largest all the way to the end. So next step is 6, since that's the largest. Since now 8 is completed, you could just forget about the end. Now 6 is the largest. What you want to do is flip that to the front, which swaps it with 6 and 4. Now you can swap that all the way to the end, which swaps it with 6 and 2. Now we have 6 and 2 completely sorted, so you don't have to worry about that. The next largest array would be 4. So you swap 4 and 2. Once you get 4 all the way to the front, you can swap it and all the way to the next end of the array, which is going to be 4. So you swap that with 3 and 4. So now the array is left with 2 and 3. And you realize that, okay, we realize that the next largest is 3, and what you want to do is that since that's already in the front, all you have to do is just swap it to the correct position, which is after 2, and now you see that it's okay, it's completely swapped, and it's in the correct position, and the sorted array is 2, 3, 4, 6, 8. So yeah, so that completely works. No issues with that. That's pretty much the main gist of how Pancake Sort works. Just find the largest element, make that the index, swap it to the front, and it's trade places with the original element that was in that position. So as you can see, that 8 and 3. Then after you have eight, the largest element in the front, the index, swap that all the way to the end. And yeah, just keep doing that all the way in the end till it's completely sorted. So yeah, I think it was that. And yeah, so here's my references that I use. I just use a little bit of the class textbook because, like I said, it does implement uh, some parts of other elements that we use or algorithms that we use. And I also found this source on the internet that spoke about pancake sorting. So that's pretty much it. Yeah, so thank you for listening. I hope you understood and can gain use from this lab about pancake sorting. And yeah, so if you have any questions, please feel free to email me. And yeah, that's all. Thank you very much and have a good day.